Hi, this is Kevin Trainer, and I'd like to welcome you to my lecture on Chapter 6 of the Murach MySQL book, 2nd edition, and Chapter 6 is entitled How to Code Summary Queries. I'm going to leave the objectives for you to read on your own. So far in our work with the select statement, we haven't been summarizing things at all. We've been pretty much getting one row in the result set for one row in the base tables that we are querying. And that's fine. Okay, there's a lot of use for that. But of course, there are times when we want our information to be more summarized than that. For instance, we might want the average of a bunch of observations, or the sum, or the minimum, or the maximum, or we may want to count them. Okay? And in this chapter, we're learning about these aggregate functions. They work like the functions we've already seen. We've seen the concat function already, except that they do aggregation of rows, and that gives us the opportunity to answer some questions more succinctly than we would be able to answer otherwise. So let's take a look. So here's a sample summary query. Select count of asterisk as number of invoices, sum, and then we have an expression. So invoice total minus payment total minus credit total. So that's the net owed on the invoice as total due. Okay, so what do we get? Well, we get a count of invoices. So we get a count of the rows from that count of asterisk. And we get a total due, $32,020.42. So what do we mean by that count of asterisk? Well, that expression counts the rows that qualified. Okay, so these would be the rows that would qualify if we were not summarizing this. Okay, so this answer set was contributed to by 11 rows. Okay, that's what the count is, and that's what the number of invoices is. Okay, so about what you would expect. Pretty handy stuff. Here's a summary query with count, average, and sum. So the first thing that we're doing is that we're doing a select, and we're providing a literal after 1/1/2014 as the value for the first column, and that's just kind of serving as a row label. Then we want a count of asterisk, so a row count as number of invoices. Then we want to round the average of the invoice total to 2 decimal places. Okay, so when we take an average, we're doing a division. Okay, and even though each of the invoices probably has an amount that is dollars and cents, when we divide, we could have fractional cents. So we are rounding the average in order to get rid of fractional cents. We're calling that average invoice amount. Okay. And then we're going to sum invoice total as total invoice amount. So after the selection date, 114 invoices qualify if you remember the numbers of rows in the table. That's all of them. The average invoice amount, $18.79.74. The total invoice amount, $214,290.51. And if we did the math on this, it would come pretty close to proving out. Okay, we might be off by a cent or two because of rounding, but not by much. Okay. Here is a summary query that uses min and max. So again, we're using, we have a select. We're putting in a string literal into column 1 as kind of a label, calling it selection date, and then where the first one is a count of the rows as number of invoices. We want the max of invoice total as highest invoice total, a min of invoice total as the lowest invoice total, from invoices where invoice date is greater than that beginning date, and again all the rows are greater than that beginning date. We get 114 of them, and there you see the highest invoice is just under 38,000. The lowest invoice is just $6. Here's the summary query for non-numeric columns. Okay, so we're going to select the min vendor name as first vendor, the max vendor name as last vendor, count vendor name as count vendors. So min will just take the first one in the collating sequence for the strings that are used for the vendor name. So that's how we get Abbey Office Furnishings. The max are going to give us the last one, Zilka Design. And then the count of the vendor name, that's going to give us the count of all of the vendors that had a name that was not null. Okay? Now, is that going to be all the rows? Well, it would be all the rows if we had a constraint on the column that said that the vendor name could not be null. And it'd be a pretty good idea to have one there. But if for any reason there's a null in a vendor name, then that's going to reduce the value of that count vendor name by 1. So if we really wanted to add up the number of the rows, we would say count asterisk. That would count all the rows. And if we say count vendor name, that's going to give us a count of all the rows where vendor name is not null. Okay? Distinct. Okay. Now, there are times when we're trying to come up with lists of things where we don't want any duplicates. Okay? And then there are times when we want to count on the basis of how many things would be in that list, not considering duplicates. So when we add this distinct keyword, it has the meaning of not considering duplicates. Okay, so we say select count of distinct vendor ID as number of vendors, count vendor ID as number of invoices, round as average invoice amount, sum as total invoice amount. Okay, so we are only getting 34 vendors, which means of the 114 invoices, they are only for 34 vendors. Okay, because we're not considering the duplicates. Okay, so several of the invoices are for the same vendor. Okay. Okay, now we can get a little fancier on this by using the group by and having clauses. Okay, so if we use all of the possible clauses, we can say select in our select list from the table source, and then we can have a where, we can have a group by, we can have a having, and of course we can have an order by. So let's take a look at that. So here on slide number 10 is a summary query that calculates the average invoice amount by vendor. So select vendor ID, and then we want to get an average of the invoice total, but we want to round it to 2 decimal places because we don't want fractional cents as average invoice amount. And that's going to come from invoices group by vendor ID, having average invoice total greater than 2,000. So we only want lines to qualify when they're greater than 2,000. Order by average invoice amount descending. Now, something to kind of understand about the having clause is here's a way for us to further select. You know, the where clause allows us to select the base rows that qualify as being in the base answer set table. Okay, but of course, once we group them, okay, then what if we want to further narrow it down? So once we have, for instance, grouped them on vendor ID, now we only want the ones that have an invoice total greater than 2,000. So the having clause allows us to do further selection after the summarization and the grouping by. Okay? Pretty cool stuff. Here's a summary query that counts the number of invoices by vendor. So select vendor ID count of asterisk, so count the number of rows as invoice quantity from invoices group by vendor ID. So here we see we got 34 rows altogether, of which we're currently seeing 4, and we see the quantity of invoices each of those has. Okay. Here's a summary query with a join. Okay. So we're going to select vendor, state vendor, city count of the rows as invoice quantity. Then we want a rounded average of invoice total as invoice average from invoices join vendors on invoices vendor ID equals vendors vendor ID. So what we're essentially doing is that we're joining the invoices and vendors table so we can have the vendors table details, and then we want to group by vendor state vendor city. So based upon the vendor state and city, we can see what the invoice average is. And I'm not really sure why we would want to do that unless we're buying all the same things, right? I don't know what to do. Perhaps we could have the people in our purchasing department could say, you know, we're buying things from too many people. What we ought to do is go hit up the vendors who sell to us in each of the locations and get one preferred vendor. So let's see who we're buying the biggest things from. I don't know. That's about the only kind of thinking that would go into that would be in any way rational. Here's a summary query that limits the groups to those with 2 or more invoices. So select vendor state, vendor city, count of the rows as invoice quantity. And then we want a rounded average as invoice average. And from invoices join vendors. and we want to group by vendor state, vendor city, having count of the rows greater than or equal to 2. Okay, so we just don't want we don't want the small players there. Okay, so maybe the same kind of thinking as to why we're doing the query, but we want to get the noise out of the answer set. We don't want to see the vendors that have less than 2 invoices. Here's a summary query with a search condition in the having clause. So select vendor name, count of the rows, rounded average from vendors join invoices, group by vendor name, having average invoice total greater than 500. Okay, so again, this is a case where we can do further selection. This isn't a case, if we just wanted to select the rows that could contribute to this result set, we would have used a where clause. Because what we're trying to do is we're trying to take these summary rows created by the group by and have a condition that selects on that. That's why we have the expression in a having clause. Okay, so it creates a whole kind of second level of selection power. Very powerful stuff. Okay, here's a summary query with a search condition and a where clause. So again, select vendor name, count of the rows, rounded average from vendors join invoices, where invoice total is greater than 500, so that's a where. By vendor name. Now, I just want to say that this is limiting the number of rows that's going to participate from the get-go. So first the where is applied. Okay, so we know how many rows qualify for a summarization. Then we summarize, then we apply the when. So in the previous example, we didn't have a where clause to cut down on the original group of rows. So we got the original group of rows, we summarized, and then we selected from that. With the having, here we've done kind of the opposite. We got the original group of rows, we limited it with the where clause, and then we did the grouping and the summarization. Here's a summary query with a compound condition in the having clause. So the having clause, which of course is going to be applied after the grouping and the summarization, it can be as complex as you'd like it to be. So what are we doing? We're selecting invoice date, count of the rows, sum of the invoice totals. Again, you don't have to round with the sum because there's no division. We're still going to have dollars and cents with a sum. From invoices, group by invoice date, having invoice date between 2 dates, and count of the rows greater than 1, and sum of the invoice total greater than 100. Order by invoice date. Okay, so lots of power here. Lots of power. The same query coded with a where clause. Okay, so because the first part of that having clause was general, could be applied to all the rows, well then you could express it in the where clause. So in this version, the first condition, the invoice date between, we're taking care of in the where clause, but the rest of this, the count of the rows greater than 1 and sum of the invoice total greater than 100, because those are selections that are based upon the summarized data that can only appear in the having clause. Okay, because the having is applied after the summarization. Here's a summary query with a final summary row. Okay, so we haven't done this so far, but we have the possibility that we can ask for with rollup. Okay, and that'll give us a summary row. So select vendor ID, count of the rows as invoice count, sum of invoices from invoices grouped by vendor ID with rollup. Okay, so the last of the rows is going to have a total for the whole query, a final summary row. Okay, and just offhand, I'm thinking that that row is not going to have a vendor ID because it's a summary. It's not for a particular vendor ID. So I think if we saw that summary row here, it would be null. So I'm thinking that to see the summary row, we'd have to go over to the control on the right-hand side and scroll it all the way down. And then we would finally see the summary row at the bottom, which again would have a null in the vendor ID column. They probably should have shown us that, huh? And here, there's a summary query with a summary row for each grouping level. Okay. So we have select vendor state, vendor city, count of the rows as quantity vendors. From vendors where vendor state in Iowa and New Jersey, group by vendor state ascending, vendor city ascending with rollup. Okay, so we're getting on each vendor state vendor city combination, we're getting a summary row. So the third row that we have, it has a null in vendor city. That's the total for all the cities in Iowa. The seventh row is for all the cities in New Jersey. And the eighth row, which has all nulls except for the quantity of the vendors, is for all the cities in all the states that qualified. So there we are. That's summary queries. It's getting started on our analytical work. And as you'll see when you watch my demo, it also is a feature that we're going to need if we have data that is summarized. Sorry, not summarized. Oh, okay. In particular, let's say we're working in the order management database, and the amount, the total of each invoice is not really in the invoice table, and to get it, you have to go to the order item table, and you have to add up all of the amounts. Well, you really can't do a query that shows the amount of each invoice without being able to do a sum. Okay, so and the fact that we're not keeping the total in the orders table is because in a properly normalized database, we don't keep redundant data. If it can be calculated, then we don't keep it. So in that kind of a world where some of the tables would have had a total in them, except for the fact that the total would be redundant, we can't really get a lot of useful answers without this sum function that we learned in this chapter. So it's not just analytical; it's really pretty basic to those kinds of use cases. And when you watch my demo, you'll see it at work. Bye bye. See you next time.